Hey guys. All right, I hope you're having fun in the snow while I make this or drinking some hot chocolate or something. All right, what I'm going to do is I'm going to go over some new integrations that deal with inverse trig. Okay, and it's going to be a short little slideshow, but then I'm going to hopefully work some problems for you. All right, your test, this is kind of the last thing that's kind of going to be on your test. Okay, so we'll talk about your test when we meet on Zoom. All right, so let me kind of share this with you, hopefully. And let's see what we got going here. Okay, so these are inverse trig integrations, like integrals. Now, these are the only formulas that I'm going to give you on a test. Okay, so I'm not going to make you memorize these. All right, I'm going to write these three things on the board, but you do know how to use them. You have to know how to use them. I'll be able to talk in a second. Okay, so these are just three forms that you see. Now, what I need you to notice is this. A is a number. It's a positive number. So A is a number and U is a variable. All right. So this says if you have the square root of a number squared minus some kind of variable squared, and you have du on the top, like the derivative of u, with, d in that letter, then your answer is arcsine of u over a plus c. All right. Now notice there's not a root down here. If you've got a number squared plus a letter squared on the bottom, and you've got the derivative of u up here with the du next to it, that's like the differential, then it's 1 over a arctan of u over a plus c. And then here's the one that's arcsecant. So you've got a u in the front, that's a letter variable squared. And then you've got the square root of some kind of variable squared minus a number squared under the root. Then your answer is 1 over a arcsecant of the absolute value of u over a plus c. Now, when I look at these, the first thing I do is make them fit the form, and then I write down what a and u are. Let me show you what I'm talking about. Now, look at this one. Now, what did we change roots to every time before this? Roots have always turned into powers. And I'm still going to try to think about that. You'll see in a minute. I'm still going to think, oh, I could turn that into a power. All right. But that would be a 1/2. And if I moved it to the top, I'd have 4 minus x squared to the negative 1/2, but I would not be able to get the derivative of the inside. So it's not going to be power rule. It's got a fraction, but it's not natural log. So I think, well, maybe it's one of these inverse trig. Now notice I've got a number squared minus a letter squared. All right. What do you square to get 4? Don't you square 2? And what do you square to get x squared? X. So do you see I've got a number squared minus a letter squared under a root, an a squared minus a u squared. So if it's going to fit this one, that means that a is what is the number inside the parenthesis. It's not 4, it's 2. See, it's the number squared. All right. And then my u is the variable inside that I'm squaring. So my u is my x. Now for this to work, I have to have du on the top. So the derivative of u. Now that makes me think I need to fix something real quick. All right. I don't need 2 dx's. All right, so that dx right there doesn't need to be there. Okay, so what is the derivative of my u? Well, the derivative of my u would be 1. Well, I really have a 1 there, and then there's my dx. So there's my differential of u right there. So according to this, I just write down arcsine and put my u over my a. We said our u was x and our a was 2. So I just recognized the form and wrote the answer out. Okay, look at this one. Now this one, I notice I don't have a root. The first thing I notice is it's a fraction. So my first thought would be natural log. But what's the derivative of that bottom? See, the derivative of that bottom would be 32x. And I can get the 32, but I can't get the x. So it's not natural log. All right. So then my next thought is, well, maybe it's arctan, because arctan has a number squared plus a letter squared. Well, commutative order of operations, commutative property of addition says that I can switch that if I need to, if that makes you see it better. So that's an a squared plus a u squared. And you say, well, 3 is not anything squared. Well, couldn't you, if you square the square root of 3, isn't that 3? So it didn't say that a had to be an integer, it said a had to be positive. All right, well, what do you square to get 16x squared? Wouldn't you square 4x? So do you see that my a is the square root of 3 and my u is this thing right here inside, so my u is 4x. Well, now on the top, you need the differential of u. So I would need the derivative first. Well, what's the derivative of u? Let's put that right there. What's the derivative of u? Well, the derivative of 4x is 4. So I need a 4 and a dx. Well, I can multiply by 4 if I also multiply it here by 1/4. So I've got an a squared plus a u squared, and up here I've got the differential of u. So according to my formula, I put 1 over a. So there's my 1 over my a. Now that 1/4 was in front, so I had to keep it. So there's my 1 over a, and then arctan of u over a. My u, remember, was 4x, and my a was the square root of 3. So I get 1 over 4 to the square root of 3 arctan of 4x over the square root of 3 plus c. So you don't have to memorize those formulas, but you do have to be able to use those formulas. Okay, now let me kind of show you what I want to try next. All right, I want you to copy down these next 2 slides. All right, and then I'm going to go work them. All right, hopefully that's what I'm going to do. Okay, so you're going to have on your test next week, all right, you're going to have integrations all mixed up. And sometimes they look very similar, but they're not worked remotely the same. Okay, so I want you to copy these 3 on a sheet of paper. And then in just a minute, I'm going to go back and work them. Okay, so kind of freeze the video and copy these 3 down. Okay, and then notice what happens. They look very much the same. So I see lots of things here. I see fractions and roots. So I might be thinking natural log. I might be thinking I could change it to a power. I might be thinking, oh, maybe it's one of those inverse trig functions. All 3 of those possibilities pop in my head for all of these. Now think about if it's natural log. If it's natural log, then I've got to be able to get the derivative of the bottom on top. Now remember what that bottom is. That bottom is an x squared minus a 1 to the 1/2. All right, that's what's on the bottom right there. Well, if it's natural log, I've got to be able to get the derivative of this on top. Well, what's the derivative of that? Would the derivative be like a 1/2? The power would come down. Your expression would stay the same. All right, then your power would go down by 1. So 1/2 minus 1 would be a negative 1/2. And then you would need the derivative of the inside, which would be a 2x. Well, there's no way to turn x into all that stuff. So this one can't be it. Same thing. Here I got to use the product rule. That's not going to be natural log. All right. What about this, though? What's the derivative of that bottom? Well, see, the derivative of that bottom is just 2x. I can turn that into 2x. All right. So this one, I can multiply by 2 there if I multiply by there by 1/2. So I've got 1/2. All right, I've got something on the bottom and its derivative on top. So that means it's natural log. And then I have the absolute value of that bottom. And then plus c. Well, now what about these? Well, now I do notice that the derivative of just the inside would be 2x. This one's going to be power rule in a second when working. I'm going to bring it up and use power rule. That one looks sort of like the form for arcsecant, because you got something in front of a u squared minus an a squared. Okay, so copy those 3 down. All right, and then I want you to copy the next 3 down. All right, the same thing. These 3 look fairly similar, but they're not going to be remotely worked the same way. So freeze it, and then we're going to go work these three as well. Okay. All right. Hopefully you got all those in your notes. So what we're going to do, I hope, is I'm going to go work those. All right, but I don't want that. Instead, I want this whiteboard. All right, so let's see if we can work those other problems. All right, so go back to this one. Okay. All right. All right, so you had the integration of an x dx over, you had the square root of x squared minus 1. That was one of them. And then your other, remember, was you had the integration and you had a dx and you had an x and then you had an x squared minus 1 dx. And then we already worked that third one. Okay. So look at this one right here. Well, we've already talked about that natural log doesn't work. All right, so the first thing we learned to do with roots, remember, is we learned to change them to powers. So remember what I said, you're going to have to force yourself to go from the first thing you learned to the last thing you learned. Okay, so what do we do with powers? We brought them up. So I've got an x squared minus 1. Now, when I bring that up, that's going to make that a negative 1/2. And then I've still got an x, and I've still got that dx. So if it's power rule, remember what we have to do? We have to do the derivative of the inside next to it. Okay? So what would be the derivative of the inside? All right, the derivative of that inside would be a 2x, wouldn't it? Well, I can multiply by 2 if out here I multiply by 1/2. All right, so I've got something to a power, and this 2x right here is just the derivative of the inside. So the power rule says that my expression stays the same, and I add 1 to my power. So a negative 1/2 plus 1 is a positive 1/2. Now, what's the same thing as dividing by 1/2? Wouldn't that be multiplying by 2? Okay. So those 2's are going to go out. So I've got an x squared minus 1 to a 1/2 plus c. And when you turn to the back of the book, though, they might have the square root of x squared minus 1 plus c instead. Okay. So that one was power rule. Now, this one's not going to be power rule. If I pull that up the way I did before, the x is in the bottom instead of the top, so it's not power rule. It's not natural log. So my next thought is, well, maybe it's one of those arc functions. Now, remember, this is the one, this was one of the formulas that was on your sheet. If you have a du, and on the bottom you have a u, and you have a u squared minus an a squared, then you can get a 1 over a arc secant of the absolute value of u over a plus c. That's your formula. Okay, well, let's see if we can get that. All right, I've got an x. Now, what would you square to get x squared? Wouldn't you square x? And then again, what would you square to get a 1? Wouldn't you get a 1? So looking at this form, do you see that our u would be x and our a would be 1? So a is what's the number that's squared and u is your letter that's squared. So what's the derivative going to be? Well, the derivative is going to be a 1. And sure enough, at the top, you know, that's like a 1 there. So this fits my form. So all I do is write the answer down. I have 1 over a, so my a is 1. And then I have arc secant of the absolute value of u, so my u is x, all over a plus c. Well, 1 times anything is that thing, so in the back of the book, they're probably just going to have arc secant of the absolute value of x plus c, because anything divided by 1 is just that thing. Okay. But remember, they all looked very much the same. All right. All right. kind of erase this. All right. All right, here we go. Now look at the others that you had on that other sheet. All right, the ones that were kind of trig looking. All right, I'm going to kind of copy those down. So the first one you had was, you had the cosine of 2x. And then the second one that you had the cosine of 2x and then the sine of 2x. And then the third one over there that you had, I had the sine of 2x on top of the cosine of 2x dx. Remember what I said, go from the last thing you learned, the first thing you learned to the last thing you learned. Well, the first thing you learn with cosine is that when you integrate cosine, don't you just get back sine? Okay, but you do need the derivative of your angle. All right, so what's the derivative of your angle right there? Wouldn't it be 2? Well, I can multiply by 2 if I also multiply by 1/2. So that's just cosine of an angle times the derivative of the angle. So that's just one you're supposed to have memorized. So when you integrate cosine, don't you just get back sine of that same angle plus c? All right, so that's just the first one you had memorized. Now, this one and this one are not ones you have memorized. Now, look at this one. The first thing I see, that's not a trig one that I have memorized. All right, so the first thing I see is it's a fraction. So my first thought of a fraction is, well, maybe it's natural log. So if it's natural log, I need the derivative of that sitting on top of it. So what's the derivative of cosine of an angle? Well, it's negative sine of that angle times the derivative of the angle. Well, that's pretty easy to get. The derivative of cosine is negative sine. Well, I can multiply it by a negative if I also multiply by another negative, because a -1 times a -1 is a +1. Now, what else do you need? Don't you need the derivative of the angle? Well, the derivative of the angle is 2. And again, I can do that if I also multiply by 1/2. So the derivative of cosine of an angle is negative sine of that angle times the derivative of that angle. All right. So I get the natural log of the absolute value of that denominator. And then there's my plus c. Okay. That was left over from last time. So for when I see a fraction, the first thing I think of is, well, maybe it's natural log. Now, this one's kind of weird. Now, this is not one I have memorized. But I do notice, you know, the derivative of cosine is negative sine, and the derivative of sine is cosine. This is power rule. Now, the weird thing is I can look at this 2 ways. All right, so I'm going to kind of put 2a and then 2b. Here's the way I'm going to look at it if it's 2a. I will think about that one being a power of 1, and then I've got this. Or I could think about it like this. I'm just going to turn it just to make it a little bit easier to see. I'm going to think about the sine being a power of 1 and then the other one. Now remember, your community property of multiplication says you can switch the order of that if you want to. Because I can think of both of these really have powers of 1. It's just a matter of which way I see it. Now, if I look at it this way with the power rule, I've got something on the inside. So I need the derivative of the inside next to it. What's the derivative of cosine of an angle? All right, we've agreed it's negative sine. Well, I can multiply by a negative here if I multiply by a negative there of the same angle. Then I would need the derivative of that angle. Well, the derivative of that angle is a 2. And again, I can multiply by 2 if I also multiply by 1/2. So this one is power rule. Remember what power rule says. You have your original, and then your power goes up by 1, so it's going to go up to a 2, and you would divide by 2, that same number, and then plus c. Remember, the derivative of the inside is not part of the answer. So I would have a negative 1/4, and they would probably write it cosine squared 2x plus c. This is exactly the same thing as that. Remember, this whole thing is square. They tend to write it like that. Well, look right here. If you look at it this way, what's the derivative of this inside? Well, the derivative of sine of an angle is cosine of an angle. I've already got that. All I'm missing is the derivative of that angle. So I just need a 2. I can do that if I multiply by 1/2. So now I've got something to a power, and then this is just the derivative of the inside. So remember, you have your original. Your power goes up by 1. So it goes up to a 2, and you divide by that same power. All right. So again, when you turn to the back of the book, they're probably going to have sine squared like that. Now here's the catch. This answer is right, and this answer is right, but the back of the book's only going to have one of them. Whoever made the key. They probably will go with this one because it's less work. They didn't have to multiply by negative and a 2, just a 2. But they are equally correct. So with trig, what's going to be really weird with trig is sometimes you can have multiple right answers, but there's only one right answer in the back of the book. But what's going to be true on your test is this. When you start working these integration problems all mixed up, they're going to look alike. So what you've got to do is, remember I said the whole semester, you've got to force yourself to go from the very first thing you learned down to the last thing you learned. So when I see an integration problem, the first thing I think is this one I just have memorized. When you integrate sine, you just get what? When you integrate x, you just get what? Okay. When you integrate secant tangent and you have the derivative of the angle, you just get back secant of that angle. So the first thing I do is this one I have memorized. If it's not one I have memorized, the next thing I look at is the easiest thing to me is power rule. I love power rule because with power rule, all I've got to do is get the derivative of the inside. So when I see powers, that's the first thing I try in my mind is power rule. If I see roots, the first thing I learn to do with roots is change them to powers and try power rule. Now, sometimes it works, sometimes it doesn't. All right. If it's a root and power rule doesn't work, then I think, oh, maybe it's one of those inverse trig ones that I learned. If I see a fraction, the first thing I think of is, oh, maybe it's natural log. But then I've got to get the derivative of the bottom sitting on top of it. All right, so all the rules that you've got a running list. Now, like I told you, for me, use substitution's way at the bottom. It's like the last thing I try. For some of you, though, you'll try use substitution way at the top. So just make sure you have all those integration formulas memorized. The only ones you don't have to have memorized are those inverse trig ones, those 3 I just showed you. I'm going to write those on the board. Okay, but start practicing them all mixed up for your test. And if you need some help, make sure you let me know. See you later.